Hi, and welcome to my video tutorial on logarithms. Okay, so first we start with the fundamental definition of a log. Log to the base a of b is equal to x simply means b is equal to a to the x. That statement and that statement are two ways of saying exactly the same thing. Next, we looked at the change of base formula. Okay, so how I like to remember this is that the b is the number on top. Okay, so I change it to some other base, c, and b is on top, so it's the top part of my fraction. A is the bottom number, so a is the bottom part of my fraction. Okay, and in the special case where the base you're changing to is b, then log to the base b of b is 1. And we can call this the swap base formula if you like. I'm not sure if that's a proper word for it, but if I were to swap the bases, then it's 1 over log to the base b of a. Okay, so we can make up a name for it and call it the swap base formula. You swap these two, you take the reciprocal. Okay. Okay, so we're going to look at this question. And the key to this one is to change the bases so that they're all the same. So I've underlined in green all the bases that are the same. Okay, there we go. Now, we always change. Now, the little technique is actually to change it to the lowest base. So in this case, the lowest base is the base 3. So I'm going to apply my change of bases formula. And this one, let me just shrink this so we can see. This one on the top becomes 4. Now, when I change the base, it's log to the base 3. Remember what I said, choose the lowest one, of x over log to the base 3 of 9. Plus 4 log to the base 3 of y is equal to 9. Now, this bottom part of my fraction is not an algebraic expression, it is a number. What number does this become? 2. So, in other words, it's 4 bracket log to the base 3 of x all over 2. Okay? And we should know by now from the fundamental definition of a log what log to the base 3 of 9 is. Okay? Plus 4 log to the base 3 of y is equal to 9. We simply cancel the fraction, so 2 goes into the 4 twice, so let me just remove that and put a 2 here. Okay, so we've now changed the first equation. If I call this equation 1 and this equation 2, I've now changed the first equation with base 3. If we do the same thing to the second equation, this is already in base 3. See here? That is already base 3. It's only that one we need to change. So 6, and let me just group all this. Edit, group, so I can shrink it. So now we can see it all in one page. So this expression here is already log to the base 3. We just need to change that one. So let's change that one. It becomes 6 log to the base 3 of x. That doesn't change. This one becomes 6 bracket, very important. There's only this expression that I'm changing. The 6 is outside the bracket. Log to the base 3, because that's what I'm changing it to, of y over log to the base 3 of 27. Now, we should recognize this straight away. Log to the base 3 of 27 as the number 3. If you are stuck, whenever I see this situation, that is a number that can be found on your calculator. I repeat, that is not an algebraic expression with unknown letters L, O, and G. All right, that is a number. In fact, in this case, that's the number 3. Okay? So, without writing out too much, can I simplify that and say that 3 goes into 6 twice? So if I cross that out, I can say that that is actually 2. Is that okay? Yeah? Now, when you're watching this video at home, you can pause at any time to clarify the steps. Okay, so now we have here 2 equations, both in x and y and to the same base. So let's call this, so we've got these 2 equations. Anyone able to suggest what we could do to eliminate? What could we eliminate? Well, if I double the second equation, let me say, if I double this, I'll make the coefficients of log, can you see that's the same? So I'll circle that for you, that's the same. And the red parts are the same. So you imagine simultaneous equations. The green part I can eliminate by doubling the second equation and subtracting. Okay? I times everything by 2, so I'll do that now. So it's 12 log to the base 3 of x plus 4 log to the base 3 of y is equal to 14. Good. So now, if I say this equation, subtract that equation, we have here 12 minus 2, which is 10 log to the base 3 of x. The y's has been eliminated. We're left with 5. 14 minus 9 is equal to 5. So, log to the base 3 of x is therefore equal to a half. And again, at this stage, we need to know how to work out x. Again, it's very easy. It's just back to the definition of a log. So I'll go back yet again to this slide. What happens to get rid of that's what happens. Let's watch that one more time. That's what happens, okay? So here, x equals to 3 to the power of a half. We can now, like normal simultaneous equations, we can now substitute 3 to the power of a half back in. Okay, so let's just pick one. What is that expression become? We've worked it out to be equal to a half. Can you see it here? Okay. So now I can replace this with a half. 2 times a half is 1. So I can have here 1 plus 4 log to the base 3 of y is equal to 9. Let me just write that. 1 plus log 4 log to the base 3 of y is equal to 9. Now from here I should be able to find y. Take 1 away from both sides, so I'm left with 4 log to the base 3 of y is equal to 8. Dividing both sides by 4. Log to base 3 of y is equal to 2. Again, back to our fundamental definition of a log. We shouldn't be stuck here because we get rid of the log. What happens? Shall I show you this animation for the 10th time, or are we happy? Y is equal to 3 to the power of 2. Good. Which is equal to 9. Well done. Yes.